All right, day 3a, hyperbola. Okay, so it's the last conic section we're going to talk about, hyperbola. Our learning target is I can identify a hyperbola from its equation in standard form, and I can graph a hyperbola and label the center, vertices, asymptotes, and foci. Now, I like to think of it, hyperbola is basically an inside-out ellipse. An ellipse is kind of an oval, goes around, or if you cut it in half and flip it inside out. Okay, that's kind of what it is. And how it happens in ellipse is the distance from the two foci is always the same. Well, here it's going to be the difference from the two foci is the same. So like just pick a random point here, take the longer distance minus the smaller distance. That difference will be the same no matter what point you pick. So you pick a point way down here, this minus this will be the same as that big distance minus that smaller distance. Instead of adding, you're subtracting. It flips it inside out. Again, so focusing on difference there. So the center is at the midpoint of a segment with foci as endpoints. You could also say vertices as endpoints too. It's going to be in the middle. It's going to be the midpoint of that line or that line. The vertices is the intersection of this segment in each branch of hyperbolas. So the vertices kind of, I don't say the lowest point, but it's like the lowest slash highest point, or the leftmost and rightmost point, depending on which way it's open. The transverse axis, that's like the main axis. Okay, so this would be a transverse axis. And then the conjugate axis, which you don't really use very much, is going this way. Okay, and you probably don't see it yet. But the transverse axis is 2 times A, where A is going to be a number on bottom. So when I show you standard form, you'll see, if I put it up here, here's a standard form with A and B on bottom. So transverse is the main axis. We'll just say the main axis. And it's the one that contains the center and vertices and foci. So it contains all those things. The conjugate axis doesn't contain all the important stuff. I think the easiest way to do this is think of it when you're graphing it, we're going to be drawing a box. Okay, and what we're going to do is figure out what is A, what is B. A tells you how wide it is or how tall it is, depending on what direction it goes. So if it's a horizontal one, A tells you how wide it is. If it's a vertical one, A is going to tell you how tall it is. So A is always how far to go to get the vertices, from the center to the vertices. And the thing is, like this one here, I've got x squared over a squared. Because it's minus, I can't just switch the order all I want. The order matters. Since a squared is with x squared, it's horizontal. If it was going to be vertical, the a squared stays right where it's at. So a squared is always first. So always first. That wasn't always true with an ellipse. With an ellipse, the a's could switch back and forth. But here, the a is always first, and what happens is this will switch to a y squared and x squared equals 1. Now, these are both centered at the origin. That's why we're not subtracting or adding anything from y or x. So there's, the true standard form is going to be on the back side of this paper, where we're going to have some x minus something and y minus something in there. But yeah, so the first number on bottom is always the a squared. Okay, the second number is always the b squared. So we want to draw this box. You got your center, you're going to go left A, right A, up B, down B, and make a box out of it. And then when you connect the corners of those boxes, that makes these asymptotes. And that's what the hyperbola has to follow, those asymptotes. So eventually they do kind of straighten out. So it looks curved and then it kind of straightens out along those asymptotes. So the box helps you make the asymptotes. So that's why I just say make a box. Okay, so let's go through one. This is nice. This is helpful. You could also find the asymptotes just by drawing it through the box yourself. But this is true here, especially whenever x is first. Whenever the y is first, it'll be a over b instead of b over a. But that's in your table that's going to be given to you on the back. So let's do this guy here. So label the vertices, the center, the foci, and the asymptote. Well, the center is going to be easier first. So let's do the center first and then go back and do the vertices. Now this one, there's no co-vertices. With the ellipses, there was a co-vertice, but with these, there's just vertices, and that's it. So the center of this guy, since it's x minus 0 and y minus 0, would be 0, comma 0. This is always the a squared. So a equals 3, b would equal 4. Okay, so I'm going to go to the center. By the bigger number here, I'm sorry, the x is first. You know, it doesn't matter the bigger number. With the ellipses, the bigger number told you whether it's vertical or horizontal. Here, it's what comes first. So this one is a horizontal one. It's going to open left and right like that. Okay, but this tells me I'm going to go left and right 3 units. I'm going to go up and down 4 units. And that makes my box. So just make a little box. You can do it light. You don't have to do it real solid here. Okay, so these are the vertices. So the vertices there, this would be what, 3, comma 0 and negative 3, comma 0. So since it's horizontal, they share the same y. Okay, they're horizontal with the center, so they're going to be on the same y. The y equals axis. You know, y in this case, y equals 0, which is the x-axis, but it's that flat line, and it's going to be left 3 and right 3 from the origin. Now the foci, if you want to do the foci now, I need to find my c. So that it's going to be, again, they're going to be on that same axis. They're going to share the same y value. They're going to be out here somewhere. But in this one, the c is actually bigger. It has to go further. It has to be outside of the vertices. So this is where before, I got it written on the back of these notes, but here we'll explain it. So to find the c, it's c squared equals a squared plus b squared. With the ellipses, it was c squared equals a squared minus b squared. You subtracted them, but here you're going to add them. So the c is longer. It's going to be longer than a and b, and it has to go beyond that. So on this one, c squared would equal 9 plus 16. You can just use these numbers, that's easier. So c squared equals 25, c equals 5. So we'll go right and left 5 units from 0. So that'd be 5 and negative 5. So there's my foci. And if I want to do my asymptotes, you could just use this formula up here, because this is the x was first, so it'd be y equals negative and then b over a and x. And then also positive, y equals 4/3 x, so positive, so plus minus. And how we find that is it's the reason why it's 4/3 is because from one corner you're going to go up 4, right 3. Well, 4 was the b, right 3 was the a. You're going to do it again, up 4, right 3. So it's the same ratio. This way it's just going down. So if I'm just drawing it, draw a line through the corner, center, and the other corner. Going this way, again, center, corner, and other corner. And that's your asymptote. So this is going to be opening up like this, and then eventually follow that straight line. Going to come down this way, follow that straight line. Go this way, and then follow that line. Go this way, and follow that line. So that's my hyperbola. Okay. So that's if it's centered at 0. Things get a little more ugly when it's not centered at 0, but they all do that. All the conic sections kind of do that. So let's flip this over. Just some things, big things to notice again. If x squared is first, then it's going to be a horizontal. That's one of these guys. If the y squared is first, it's one of these guys. The a's and b's stayed right where they're at. They didn't switch. It was y came first or x comes first. And this is the new, it's the same both ways. C squared is going to equal a squared plus b squared. The asymptotes, if x is first, is b over a, or it's a over b over here. And there's some shifts here. Now, you can actually find the equation without this. Maybe I'll show you that too, because I don't care which way you do it. It's whichever way you find easier to get it. Okay, so let's look at this guy. Again, label vertices, center, foci, and asymptotes. So first off, look at it and figure out what directions they're going. So the y is first. That means this is going to be an up and down. It's going to be a hyperbola, looks like that. So it's going to be up and down, which means all of these points, so the center, the vertices, and the foci, they'll all have the same x value because they line up vertically. So I'll all have the same x value. So I'm doing my vertices here, and my center and my foci, all of these have the exact same x value. So if this is at, x value here is, I almost messed up. So this was negative, because I always look at these backwards. So this is -3, and then this is +2. So if they line up vertically, they'll all have -3 as their x coordinate. Now it's just how far away from 2. So I'm going to go up and down from 2 and up and down from 2. So my A is 3, my B is 2, because the square root of 3 and the square root of 4. So for this one, I would go, since it's going to be vertical, this A tells me how far up or down to go. Okay, so I'm going to go, to get to the vertex, I'm going to go up A units. So 2 plus 3 is 5, 2 minus 3 is -1. And then for my, for my foci then, I gotta find my C. I'll use that B in a second. So it's gonna equal A squared plus B squared, so that'd be radical 13. So I'm gonna go, center's 2, so I'm gonna go up radical 13 from that, and I'm going to go down radical 13 from that. And then my asymptotes, like I said, I'll show you a different one. You can do what it says up here, because it's going to be this guy right here, be plus or minus a over b, x minus h plus k, which if we want to write that, y equals plus, I'll just put plus or minus and do it all at once. So it'd be 3 halves x minus, your h was 3, so it'd be plus 3, then plus k is 2. So if you want to write it that way, that's not that hard to fill it in, and you get to use these in your notes. But also using your box, you can just see the slope and the y-intercept is most of the time. So my center is at -3, 2. There's my center. I'm going to go up and down 3, 1, 2, 3, 1, 2, 3, right and left 2. And this just helped me make my box. So here's my box. And these are vertices here. Now the foci are going to be radical 13, which is between 3 and 4 units away, so it's somewhere up here in my foci, like something like that. And if you connect your lines like this to make your asymptotes, you can kind of see the slope here is up 3 over 2, up 3 over 2. That's where that's coming from. So you could say y equals 3 over 2x. And then where does it cross the y-intercept? Well, it's going to be up 3 over 2 from here, so it's going to be like something and a half. So it's a little bit harder to do if you do it just by looking at it, but that would be, let's see, be about 6.5. If you want to do it that way, and then you do y equals -3 halves x, and this is down 3 over 2, so that'd be about -2.5. Now if you simplify this, if you distribute the 3 halves out and then add all the like terms up, this is what you'd get. So I'll put a big or between those. I didn't look far enough ahead on Math Excel to see how they want it in there, so you guys let me know which method. Hopefully it takes both, but if you just want to plug stuff in, that's probably easier. Okay, the bottom guy here, again, so vertices, center, foci, and asymptotes. The center is going to be easier to find. Okay, so x is be 3, -1, and the x is first, so this is I'll just draw a left and right situation. So there's my center, here's my vertices, here's my foci. They're all going to have the same y because they line up horizontally, so they'll all have the same y value. So right off the bat, they're all going to be comma -1. Okay, so A is 6, B is 3, C is going to be the square root of 36 plus 9, so that'd be 45. So square root of 45, which is about 3 radical 5. So there's my C. So to get to the vertices, I'm going to go left and right 6 from 3. So 3 plus 6 is 9. 3 minus 6 is -3. For the foci, I'm going to go 3 plus 3 radical 5, 3 minus 3 radical 5. And then for the asymptotes, again, I can look up here and just copy this down. So if you want to look up there, I'm going to write it this way. So it would be plus or minus, y equals plus or minus b over a. So that'd be 2, it'd be a half, if I can get it right. X minus h is 3, minus 1 is your k. So positive and negative, so there's 2 of them in there. Also I can just draw a box and I can make my asymptotes a lot easier. But so it's centered at 3, 1. And then I'm going to go right and left 6. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. From there, go up and down 3. So this is helping me draw my box. And then your foci, it's going to be just a little bit, the foci is going to be just a little bit beyond those. Let's see. Yeah, it's not quite 7 units, it's going to be a little bit beyond that. So your foci is going to be out just a little bit inside of there. I don't know if they're even worth putting in there, but I'll draw your asymptotes, draw straight line asymptotes. I didn't do so good there. And then you need to follow those. So it's going to go like this. These are probably the skinniest hyperbolas we've done so far, so it should look something like that. Okay, so do the box. The box is going to kind of help get things going, and that just guides the hyperbola. Those asymptotes guide which way to go. And figure out what direction it is first. So figure out if it's horizontal or vertical, and that just kind of lines everything up then, makes it a whole lot easier. So hopefully that helps, and just let me know if you have any questions.